The James Webb Space Telescope, humanity's most powerful and advanced eye on the cosmos, has once again transformed our understanding of the universe. Its latest revelations about Pluto, the distant and enigmatic dwarf planet at the far reaches of our solar system, are nothing short of revolutionary. Once dismissed as a cold, lifeless rock wandering the outskirts of our cosmic neighborhood, Pluto now emerges as a complex, dynamic world full of surprises, challenging everything we thought we knew. At the center of these discoveries is Sputnik Planitia, the vast, heart-shaped basin that dominates Pluto's surface. Previously believed to be a simple frozen plain of nitrogen ice, Webb's infrared vision reveals much more beneath its surface. Scientists now believe that beneath the thick crust of ice lies a vast subsurface ocean, a hidden sea of liquid water kept from freezing solid by internal heat. This discovery is profound, suggesting that even in the coldest, darkest corners of our solar system, conditions might exist that support life, or at least the chemistry necessary for it. The idea of a liquid ocean beneath Pluto's icy shell forces us to rethink what environments can sustain life. On Earth, deep beneath the ocean surface, hydrothermal vents provide energy and nutrients that support thriving ecosystems, independent of sunlight. If similar conditions exist under Pluto's ice, could microbial life survive there, thriving in a watery world shielded from space's harsh radiation? This possibility has captivated scientists, opening a new frontier in the search for extraterrestrial life. Beyond Sputnik Planitia, Pluto's surface itself tells a story of active geology and surprising vitality. Towering mountains, some reaching heights comparable to the tallest peaks on Earth, rise from its crust. Immense glaciers of nitrogen and methane ice slowly flow across the plains, reshaping the landscape over time. These observations reveal Pluto as a geologically active world, far from the static, frozen body once imagined. This activity is powered by thermal energy generated from the radioactive decay of elements in Pluto's interior, as well as gravitational interactions with its largest moon, Charon. Together, these forces generate internal heat sufficient to drive convection and even maintain the subsurface ocean. The interaction between Pluto and Charon is unique within our solar system. Nearly equal in size, the two bodies orbit a point between them, locked in a gravitational dance that creates tidal stresses and internal friction. This constant tugging produces geological activity on both worlds, contributing to their ever-changing surfaces. Charon itself is mysterious, with deep chasms and a reddish tint suggesting past interactions with Pluto, including the possible transfer of surface material. This chemical exchange could even transport organic compounds, the building blocks of life, between the two worlds. The James Webb Space Telescope's advanced sensors also detected complex organic molecules known as tholins scattered across Pluto and Charon's surfaces. These reddish compounds form when methane in Pluto's atmosphere is broken down by ultraviolet radiation from the Sun, triggering chemical reactions that produce complex carbon-rich molecules. Tholins not only give Pluto its characteristic reddish hues but also hint at prebiotic chemistry, processes that may have played a role in the origin of life on Earth. Scientists speculate about whether these compounds might mix with Pluto's subsurface ocean, potentially setting the stage for life's earliest biochemical steps. Pluto's atmosphere is equally fascinating. Though thin and tenuous, it is surprisingly complex. Composed primarily of nitrogen with traces of methane and carbon monoxide, Pluto's atmosphere extends hundreds of miles above the surface, forming a hazy veil that shifts as Pluto travels through its elongated orbit around the Sun. When Pluto is closer to the Sun, surface ices sublimate, turning directly from solid to gas and creating a temporary atmosphere. As Pluto moves farther away, the atmosphere freezes back onto the surface, creating a cycle unlike any other in the solar system. Studying these atmospheric changes provides insight into how distant worlds adapt to extreme environments and offers a glimpse into potential climates on exoplanets orbiting faraway stars. One of the most striking discoveries is how Pluto's internal heat drives geological processes beneath its icy crust. This warmth, generated by radioactive decay of heavy elements deep within its core, causes convection, slow, flowing movements of ice and nitrogen, reshaping Pluto's surface and maintaining its hidden ocean. This internal engine contrasts sharply with the previously held belief that Pluto, due to its small size and distance from the Sun, should be geologically dead. Moreover, Pluto's magnetic environment has offered surprises. Unlike Earth, Pluto does not have a strong intrinsic magnetic field. However, as the solar wind, a stream of charged particles flowing from the Sun, encounters Pluto's atmosphere and surface, it creates a unique and dynamic interaction. The James Webb Telescope's observations have revealed unusual energy patterns and magnetic disturbances around Pluto, providing new insights into how small, icy worlds interact with their stellar environments. These findings have broad implications for understanding the behavior of other dwarf planets and Kuiper belts. Looking forward, the discoveries made possible by the James Webb Space Telescope mark just the beginning of a new era of exploration. Future missions are already being planned, from orbiters that will study Pluto from above, to landers and rovers that might one day touch its surface, collecting samples for direct analysis. There is even discussion of robotic submersibles designed to explore Pluto's hidden ocean, an engineering challenge that would represent a historic leap in space exploration capabilities. As our technology advances, these missions could confirm the presence of life-supporting conditions beneath Pluto's icy shell, transforming our understanding of habitability beyond Earth. Discoveries on Pluto will also inform the study of distant exoplanets, worlds orbiting other stars, many of which may share similar characteristics with this dwarf planet. In sum, Pluto's story is no longer one of a cold, static outpost, but that of a vibrant, evolving world. The revelations from the James Webb Space Telescope show us a place with active geology, a dynamic atmosphere, hidden oceans, and complex organic chemistry. It challenges the boundaries of where life might exist and expands our vision of the solar system's diversity. The ongoing exploration of Pluto reminds us that the universe is full of surprises, waiting for those bold enough to seek them. As new discoveries emerge, we continue to learn more about the origins of our solar system and the potential for life elsewhere in the cosmos. What secrets does Pluto still hold beneath its icy veil? Could it truly harbor life? And how might these findings reshape our understanding of worlds far beyond our reach? The journey to uncover Pluto's mysteries is just beginning, and with each new revelation, humanity takes another step deeper into the cosmic unknown. The James Webb Space Telescope has revolutionized our knowledge of Pluto, but it has also raised new questions. How did such a small and distant world maintain internal heat for so long? What processes keep its surface so active? Could its oceans be home to life, or at least the ingredients for life? These questions are now at the forefront of planetary science. Moreover, the implications extend beyond Pluto itself. As we learn more about this dwarf planet, our understanding of the Kuiper belt, a vast region of icy bodies beyond Neptune, also deepens. These distant worlds are remnants from the solar system's formation, and studying them can reveal much about how planets and moons form and evolve. The discoveries also impact the search for life beyond our solar system. Many exoplanets discovered in recent years are small, icy worlds orbiting far from their stars, similar in some ways to Pluto. Understanding Pluto's geology, atmosphere, and potential habitability can provide vital clues about what to look for when searching for life on distant planets. Scientists hope that future telescopes and missions will continue to shed light on these mysteries. Proposed missions include orbiters equipped with advanced sensors to map Pluto's surface in even greater detail, landers to study its geology up close, and even probes designed to penetrate its icy crust and explore its hidden oceans. The challenge of exploring Pluto is immense. Its distance from Earth, about 4.7 billion miles, means that even radio signals take more than 4 hours to travel one way. The extreme cold and low light levels also pose serious technical hurdles. Yet, as history has shown, humanity's curiosity and ingenuity know no bounds. As we stand on the cusp of these new missions, Pluto stands as a symbol of discovery and wonder. Its story reminds us that the universe is far more complex and alive than we ever imagined. It challenges our assumptions and inspires us to keep looking upward, beyond the familiar, toward the unknown. In conclusion, The James Webb Space Telescope's findings about Pluto have forever changed our view of this distant world. From its active geology and mysterious atmosphere to the tantalizing possibility of a hidden ocean and organic chemistry, Pluto is no longer just a distant dot in the night sky. It is a vibrant, dynamic world, full of secrets waiting to be uncovered. The exploration of Pluto continues to push the boundaries of science and technology, opening new doors to understanding our solar system and the potential for life beyond Earth. As we prepare for the missions of tomorrow, Pluto beckons us to explore deeper, dream bigger, and embrace the endless possibilities of the cosmos. What do you think lies beneath Pluto's icy surface? Could this dwarf planet be a cradle for life, or at least a stepping stone in humanity's quest to find it? Share your thoughts in the comments below, and don't forget to subscribe for more fascinating journeys into space and science.